Hi, this is the last session of the chapter on insurance or insurance benefit. So in this chapter, we'll continue what we started last discussion about insurance benefit that is not level, that is either increasing or decreasing. So we looked at continuous case or death occurs at the moment, or benefit is paid at the moment of death. But now it's more realistic case that there is a gap, like benefit will not be paid at the moment of death, but it might be at the end of the year. So we look at the end of the year. So, and increasing or decreasing benefit, but the benefit is paid at the end of the year. So let's start with drawing the line. I usually like to visualize the situation, so it helps me to answer, and I encourage you in questions to visualize it. So we have an individual age x plus 1, x plus 2, x plus 3, and so on and so forth, right? So now we wanted to look at I increasing, A for the insurance benefit for x. Previously, if you recall, we had a bar either over the I or over the A, but let's focus over the A. If the bar over the A, it means that benefit is paid at the moment of death. So benefit is paid here 1, 2, 3, because why it's 1, 2, 3? Because of the I, the increasing. Now we can remove this one. If you remove this one, then things change. It's not at the moment of death, but rather at the end of the year. And if it's at the end of the year, let's take case by case. If death occurs here, then there is $1 paid here. Now, if death, I'll use different color, occurs here, then you will have the second benefit will be $2 here. Now, if death occurs in the third year, you will have $3. And so on and so forth. It keeps increasing, 1, 2, 3, 4, 5, 6. And to evaluate this one, it's easy. It's discrete. So we need to evaluate its expected value. The discounted multiplied by the probability. So let's take the first one. First $1 at the end of the year, discounted back. So it's V. Not right. It's $1 V. And the probability to claim this benefit is the probability of death, which is a QX. Now let's take the second term. Now this is $2. But you need to discount it back. So 2V, right? 2. Because it's 2 years, so we discount it back. And now for you to claim the the $2 death would have to happen in the second period. So it means that somebody would need to survive to the second period first. So PX, and then death occurs in X plus Q, X plus 1, right? Then same thing, 3V3, right? Because this is the payment. And then P2PX, right? You need to survive 2 years up to this point. And then death occurs here, then QX plus 2. And you keep going, right? You keep going. And this is straightforward, right? Just you can always, visualize it and solve a question like this. A variation of this one is you need to calculate IA. Now, let's say X, discrete, but not for the forever. It's up to point N. This is very easy because it's just you stop it at time N. So it's the same logic. You have same logic. Everything here the same. But the last term will be the last term. It's very important to look at the last term. So let's now look at time N now. X plus N. At X plus N, you would have like here the value. If you look at it, the value here will be N. So we need to have N, the last one. Now you discount it back to NVN, right? It's very important. Now you need to survive to here, to which is N minus 1 PX. Let me put it this way. And then death occurs in Q. Now we need to be careful here. QX plus N minus 1, right? Because because there is 1 here, right? The 1 will cancel with the 1, right? So we need to be careful here. And most of the time, this is, you can just, it's difficult to look at it in the formula. It can be confusing, but once you do a question, it's easy to see it, right? And this is straightforward, not really much. It's just you keep increasing 1, 2, 3 up to n. If it's unlimited, you keep going. Now let's look at also like a few identity. We'll take question, but this is a discrete case. Good questions can be in the exam because it can be, you play with certain relationships. I will show you later a question that I had it in previous year midterm. So, but let's look at certain identity that can be quite interesting to look at. For instance, what if you have a situation that you have x plus 1, x plus 2. Now let's look at, firstly, let's look at IA at x. IA at x, I usually visualize it. It will give you 0, of course, here, but it will give you 1, 2, 3, and so on and so forth, like 4, 5, 6, 7. Now, wanted you to look at now, imagine if you are here, IA x plus 1. If you are at IA x plus 1, will give you 0. Oh, let me use different color here. Now let's say IA x plus 1. It will give you 0 here, 1, 2, and then 3 here, so on and so forth, right? How we can relate them to each other? Let's try to relate them to each other. It's very important, to visualize. There are many variations, so I cannot go all over them, but you can play, with the different variation of this one. So how about you have IA x? We need to relate it to, for instance, this one, right? IA x plus 1. Right. And the first thing you need to recognize that there is 1 year delay. So this one, firstly, we need to bring it here. So how you bring it back? You discount it, actuarial discounting, because 1 year we can just VPX, right? But if you bring this one, there is $1 missing here. This, if you would see, imagine now if we add to this one, if we add AX, it will be 0, 1, 1, 1, 1. So now if you add these guys together, let me use a different color. This together will give you this. So all we need to do is to add AX. And this kind of relationship is very useful, right? I'll show you a question from last year's exam. Maybe I'll just do it to you right now. Let's take this example. This is question 10 in in previous year midterm. I had it for my students. It's based on a real actuarial exam. Right, let's look at this question from the midterm, which I will give it to you as well so you can look at. So let's look at this question here. And let's see how I can relate this. It's a bit interesting. It's not difficult, but if you visualize it, it's not really difficult. I always encourage you to visualize it. It's very important. So let's start with like what I did before. Let's start with 0x, 35, 36, the x is 35, 35 plus 1, 36, 37, 38, and you can keep going. Now let's look at the first one, what we have. Let's look at IA35. IA35. It gives you 1 here, 2 here because it's increasing, 3 here, right? Now we wanted IA36, which is here. IA36. IA36, it will give us 0 here, but it will give us 1, 2, right? So we need to add something to it to balance it, right? Similar to what we did. If we add another element to it, which is A35, it will balance. But let's look at this relationship based on what we did in previous identity. A35, we need to have IA36, right? IA36, but we need to bring it back because it's at different time. One is here, one is here. How we bring it back? It's VP35. Then we need to add to it. Remember what we did last time? We need to add to it an it's A35, because A35 will give you 1, 1, 1. So now if you add these guys, if you add the top two with the 0 here, now this will give you this. But A35 and IA35, they are at this time. IA36, it's 1 year shift, so you need to shift it back discounting. So we need to add here A35, right? So let's see what we have. Let's see what we have here. What's given to us is we are given this one. We are given, this one and this one. Oh, no, not, you are given this one. This one. We are given also IA36, right? So what is missing here is this one, V. We need V to solve the question. Let's take V on the side here. So let's look at V, how we can calculate V. What we are given here is quite interesting, this relationship. Let's try to understand what it is. Let me use this color. Let's A35 1. What does it mean, A35 1? Remember, there is no 1 over 35, so this has two terms, right? The first term is like you are, let's draw a line here. So 0, 1, 2, because it's for 1 year. So you get $1 if death happens here, you get $1. Or you get the same dollar if you survive here. So you're gonna get the $1 either case. It's certain, right? You get dollar if death happens here, or you get dollar if you survive. So it means that you're gonna get the dollar. But the dollar here, the value is V. But if you don't see it, conceptually, you can just split it. So the $1 if death happens, it's the V, you discount it, V Q35. And then you get the same dollar VP35. Factor out the V, Q35 plus P35. These are 1, which equal V. Right? So this is straightforward, right? It's just, you can immediately know, if you know what does it mean, you're gonna get dollar if death happens the first year, or you're gonna get dollar if death does not happen first year. So either way, you're gonna get the dollar, because at the end of the period it's V, right? So it's sorted out now. It's solved. It's solved. So now we plug in what we have. A35, IA35 is 3.71. A35 is 0.13. Now V, we already got it. It's 9434. Now this one we multiply it by what we wanted, which is the IA36. If you do just little manipulation here, no, not much, just you take the 0.13 to the other side, so 3.71 minus 0.13, and then divided by V, 0.9434. So I made a mistake here, sorry. Sorry, just to make sure I got the right one. 3.71 minus 0.23. Oh yeah, I'm missing something here. Oh, sorry for that. Make little mistake. Sorry, I'm missing the P35. I didn't include the P35, right? I was a little excited. So, but you need to be careful about it in the exam, not to make easy mistake like this, right? So P35.9964, then IA35. Now, once you do this, IA36, IA36, you will get it to be 3.808. So, like, this is kind of the question that, I like to ask, because it has a conceptual element to it, not so much of calculation, but rather the like the conceptual element to it, right? So again, we did this, like this relationship with IA. Now there is, we can think of also decreasing insurance, right? Insurance benefit. So instead of starting with 1, 2, 3, 4, 5, 6 up to n, now we'll start with n. But given it's it has to be 10. It must be 10. It must be 10. A term insurance. Because if it's not term insurance for decreasing, it might get into the negative value, as we discussed in the continuous case. It might get into the into the negative value. So what we wanted to do now is just to define it, right? Let's define this decreasing case as well. So it's DA, sorry. And if you have the DA, let's visualize it first. You start with X up to N. 1, 2, 3. So we'll start here 0, of course. Now here we start with N. N minus 1, the benefit. N minus 2, all the way, the last term will be 0, right? And this is the decreasing benefit. So the last one will be 0, right? Actually, the last one, sorry, will be 1. Sorry for that. Yeah, it will be 1, right? So the last at the end of n minus 1 here, end of n minus 1 period, you're gonna get $1, right? So now, if you want to write down this relationship, then you will write the first one will be n v1, right? qx plus. The second one now, it will be n minus 1. Oh, sorry, it has to be, as I mentioned, term benefit up to n. This benefit must be term DA for insurance for x up to the point of n, right? And then you have n minus 1, right? V2, see it's V2. Now you survive PX, then death happens. Then what you need to do is now you add n minus 2, V to 3 now, right? And V to 3 now you have P to PX, because you survived to 2PX, and then you have a QX plus 2. Keep going up to the term of n. Now the last one will be, the last benefit is, will instead of n minus 2, now you exceeded everything, it will be 1, the last one. Now V, because 1 paid n, Vn, right? And now you need to survive to Px, you need to survive n minus 1, and death happen at qx plus n minus 1. Right? This is how it will look like, the relationship. Right? So we need to keep this in our calculation. Right? So let's take one example, or this one is quite straightforward. You don't need to do much about it. But I wanted the same thing we did with the previous one, is to do the relationship, because there is one equation in the assignment related to this one. In the assignment, we did one on the IA. Now there is another one on DA. So the DA is, imagine now you have this relationship, right? You have x plus 1, x plus 2, all the way to, let's say, all the way to n. Right? So the benefit you get here is you get you get n. For DAX, you get n minus 1, as we discussed before, and all the way the last one will be 1, right? So now what we'll do here is, imagine if you have, now you're looking at another relationship. Now DA x n x plus 1, because we are here for now n minus 1. Right. And let's try to see what will happen here. Here it will give us, now for this one it will give us n minus 1 here. Oh, sorry, here it will give us 0. Let me use different color. Here it will give us 0. Here it will give us, the first one will be n minus 1. Right? And you keep going all the way here, right? Which will be the last one, will be 1, similar to that one. Now let's try to relate them together, right? Just let's see what is the story here. DA for x n. Oh, there is 1 here, right? Sorry, there is 1 here. There is 1 here, sorry. There is 1, sorry, like there are ones everywhere here, so sorry for that. So this one now, we need to relate it to DA x plus 1. There is 1 on top of it, and minus 1. First thing, you need to make sure that we cancel them out. The ones they together, we cancel them out. So everything will cancel out except that this is at x plus 1. So we need to bring it back. How we bring it back? It's we need to discount it. We need to discount it, and then also Vx. So we need to discount it and multiply it with the probability. We still have something missing here, right? We still have this one. We didn't account for it. So now we have the n. How the n will be paid if death occurs here, and n is a qx, but it will be at the end of the year, then v, right? And this is very important, like to keep it in our mind. So let me make sure I give you the correct one. N qx v px dA x plus 1 n minus 1, right? This is another relationship that really, it's not about memorization but ability to visualize it and write it down. So like this is like this relationship here. I give you one question which I asked it in the midterm last year. There is another question on this one, this relationship. It's in the assignment, so I encourage you also to solve this question, given that they are very important. So with this one, it's I think, yeah, let's take another example here, a different example. This is like $1, but what if you are given 1,000, 2,000, 3,000, or 100,000? Let's take a life that is age 70, 71. Let's make it simple, 72. And let's say that there is a benefit amount of, let's do 100,000. Let's make it big. 200,000, 300,000, or any value, you know, like 1,000, 100, you know, 50, you know, with a multiple of 1, right? This one, or any value you want, it doesn't have to follow, you know, easy number. We need some information here. You also given what we are given. We need I. So let's take I of 5%, maybe. Yeah, let's do 5%. Just to make sure I give you the correct one, 5%. And we need Qx. So let's, for simplicity, let's have a Qx plus K, and X here is 70. Let's say it's given to us by a specific formula that is 0.02 multiply 1 plus K for K012, right? So we given all we need. Just because, you know, like the question, usually the K is, remember, if it's, maybe if we visualize it, 70, 71, 72. So K is 0, 1, 2. Maybe we can write it here. Let's solve this equation. And what is the question asking us to find? The expected value of the present value of this benefit. So we need the present value, the expected value of it, the actuarial present value, or the actuarial present value of this benefit amount. So it's a 3-year term insurance. You know, you can write it, you can try to write it with 100, you know, we can try to write this one as 100,000 of IA 70 for 3 years, right? But let's complicate it, you know, let's not complicate it. Let's not use this. Just what the point, I wanted too many formulas, but it makes sense. It should make sense. So let's try to solve it directly without, you know, using notations, hard notations. Let's add firstly K. I'll use different color. So I'll add K just to help us, 0, 1, 2. Right? What else we need? We need QX or QX, yeah? So QX, if K is 0, it will be 0, 2. If K is 1, I plug in here, so 1 plus 1, 2 is 0, 4. What if this K is 3 is 0, 6, right? Simple. Now this is easy. So now the expected value of Z, of this insurance, the expected value of Z is, we take the same logic, the benefit amount 100,000 multiplied by the V, because at the end of the year of V1. So if you draw a line, it might help us. 70, 71, 72, 70, yeah, 3. So we have 100K, 200K, 300,000. So for the first 100,000 to get it, you need to discount it back, and you need death to happen at Q70. Plus, second 200,000, you need to discount it 2 years because it's here. And then you need to have P70, Q71. Right, it's simple. Now the third value, 300K, now we need to discount it 3 years, and then the probability, because its expected value is TP70, Q72. Right, it's simple. You plug in. Let's take 1,000 or 100,000. Factor it out. It's easy. Now Q70. What's Q70 is 0.2 plus V2. Now P70, the opposite of this one, 0.98. Now this one multiplied by the second mortality 0.04 plus V3 0.98.96 surviving the second year, and the last one is the probability of death 6%, 0.06. So really we didn't need to use IA, you know, it's just we solve it right away, the same logic. So all we need to do is now, if you calculate this one, it will give you 23644. This is the value of this insurance for this special insurance. So really sometimes you don't need to complicate it and use the notation. You might be asked what is the expected value of Z2, second moment. Second moment, it's the same thing here, right? You take the same thing here, except you raise these guys to 2, and you raise these guys to 2, you raise these guys to 2, right? And if you want the variance, then you take the expected Z2 minus the second moment minus the first moment squared. So this is very much, you know, not much of complication here. It's just you need to be careful when you write it down. The last thing, you know, is how we relate this increasing insurance, the continuous case, with the discrete case. Like what we did with the level insurance, we need assumption of UDD, uniform distribution of death. Under these assumptions, what we can do is we have IA, the payment is paid at the moment of death for X. You can just simply calculate it by, you have again the same logic, I over delta of IA X. Now the same thing with the term, with 1 here, I delta I A I KX and this one, right? It's the same logic with DA, the continuous case for $1 is equal to I delta DA X $1 and right. The only thing similar to what we did, this is, remember, there is $1. If there is no $1, yeah, you need to be, this is term insurance, right? Term insurance, just like the previous case. And now we finish this this session. So now you have a large problem set to try to solve them all. If you have a question in the live session, let me know.